What's up, everyone, and welcome to Boxmining. Today, we're going to take a look at a very different project in the crypto space, which is Trias. And Trias, the project, is about having trust in machines. And when I first saw this, I'm like, dude, is it Skynet's coming? Is it that soon? Do we need to trust the machine and the AI algorithms? And the simplest way to describe it, if you're a gamer, is if you play video games, there's going to be cheaters. So essentially, they're hacking their machine to gain an unfair advantage in a video game. We can't trust their client, their machine. And this isn't just in gaming. In a lot of enterprise applications, in IoT devices, and in AI, you need to make sure you trust the machine and the code that's operating. And this is why trusted computing is a huge field. And I interview one of the specialists, Dr. Rang Anbang. He's done his doctor of philosophy on this subject, and he's also the CEO of Trias. So he solved this problem using an approach that we all kind of are familiar with. The legal system is separated into 3 different components, each of them with limited powers. And he's also dividing his blockchain into 3 components. And we talk about why this is important in the industry it applies to, because not everyone wants to bring everything onto a dApp. They want to run on their own software and code as well. And this is why Trias is there to make sure that this is legitimate enough to use and to share between everyone in the network. I hope you guys enjoyed this video and learned something from it. So Dr. Ron, can you tell us a little bit about what Trias is about?
Thank you, Michael. Yes, Trias is all about building trustworthy machines. So we use it in the separation of powers way. So by separation of power, we need first to define the executive, which is a machine, who can run the actual correct code. And secondly, we need a legislature, which is a law defining the actual behavior of the code. So this is the second system. And the third one is the judiciary, which identify who does what, who will get what, and who, if anyone does anything bad, they will get punished. So we use this philosophy in the cyberspace, and we try to try a system to allow people to identify what is really going on inside the cyberspace.
Right. So you've been looking at the idea of trusted computing. What does trust mean when it comes to computing?
Right. If you, for example, if you want to trust someone, a guy, this means that he will actually do what he said, told you to do. So by trusting a machine, for example, when you open the application on the machine, when you send the data to it, you are actually expecting that machine to process the data in a specific way and return the data to you. But actually, a machine up to now is a black box. You don't really know what's going on inside there. And we all know that a machine is driven by applications. So basically, we need to solve 3 kinds of problems. For one thing is that we need to know whether this piece of machine can actually load and run the given application, the piece of given application. There are situations that when I give an application to a machine, and because the machine was hacked, so that machine actually hacks my application by adding some minor patches or implementing some malicious behaviors. It's just like a virus. So right. The first thing is very critical that can we actually trust one machine can actually run the application that is given by us, human beings. Yeah.
Right. So, and I was thinking about this earlier. The examples I kind of thought of was when you're playing a video game. When you play games, especially competitive games, there are some people who choose to hack the game and introduce something like a program that can help them aim or even see through walls to give them an unfair advantage. So what you're talking about here is that you're trusting the environment that the application will run as promised, kind of, as you're trusting that the application is free from external hacks, right?
Regarding the gaming applications, one thing is that when we or someone else, when I get the application, the binary data of the application, we might have the incentive to change that binary a bit so that we can cheat inside the game. Also, maybe some other people can cheat inside the game. So in order to dictate what a machine will behave, we somehow need to change the application. Yeah, so the basic layer of Trias is what we call the Leviathan network. It's actually a trusted computing network. By trusted computing, we mean it to be a specific research field in the operating system security research area. Yeah, so we use a small chip, which is called the TPM, and currently we also use the Intel SGX capability to act as an TEE. So with this kind of chip, so we can actually know what kind of application has been loaded inside the target machine. So with this capability on board, we'll be able to tell whether your machine is running the given application. So this is the first layer, the first thing we're going to solve, a trusted computing environment which can run a given application. Yeah.
So that's the first layer. And then what is the second and the third layer? Because you're Trias, you expect 3 layers, right?
Think about the other question that given an application, because the application is developed by a third party, how can we tell that that application is generally doing the right thing? For example, if we got the correct machine, but that application itself contains malicious behavior, so that behavior will be correctly enforced, then yeah, we still got cheated. Yeah. So the second layer is all about telling the origin of a piece of application. Yeah. So we use another technology called Promise. We use blockchain to record the entire life cycle for developing a piece of software. It's just like if we can have a recorder to record a human baby, piece of her entire life, then we might be able to tell piece of a character from their past behaviors. So it's just like we put a camera onto the actual development process, or the entire development process of the application. Then, for example, we can record the identification of any piece of source code, and we can tell this source code has been compiled into this kind of binary objects and then assembled together to this application. So with this capability enforced, we will be able to tell whether this piece of application contains malicious behavior, because if we agree that all behaviors have to be coded inside the application.
So layer 1 is about the machine, layer 2 is about the application, and then what's the final layer?
In order to build a large service, we need to coordinate trusted machines with trusted applications. We need to know that this piece of data has to be sent to that application running on this kind of machines. So the third layer is actually our smart contract layer. And we are thinking about using this kind of smart contract languages to write decentralized software as a service. It's a little bit bigger than the decentralized app because, software as a service is a combination of different applications and they work together to implement a service.
Now all of this is kind of like completing the tree cycle. So you have trusted machine, trusted software, and then your software as a service. Now, what kind of problems does this solve overall? So you built this amazing machine. What is kind of the target solutions?
In my point of view, or in our team's point of view, the future of blockchain lies in enable trustworthy enterprise applications. What the smart contract can really solve is that it can help enterprise to prove itself trustworthiness to their customers. It's like when we send data to Facebook, we actually don't know where our data is stored, whether our data is analyzed, or who saw our data. So if we got a way to build the entire Facebook infrastructure as a blockchain smart contract, imagine that entire Facebook infrastructure as a blockchain smart contract. So we will be able to tell any piece of what has been going on inside that big application, who has touched our data.
So right now, that's a kind of scary part. We passively trust a lot of companies, whether it's Facebook or Apple or Google. We trust that they're not doing something really a lot of spying on our data. But what you're saying that with Trias is that if they migrate their services onto Trias, we can know for a certainty that the execution is going to be clean and that there's no funny business when it comes to our data, and even consumer and enterprise usage. You can just trust the execution.
Yeah, it's all about trust. It's also about trust. Yeah.
Right. Okay. So you're talking about this trust and you're adding the blockchain element to it. Now, one thing about blockchain is that it's all public. So how do you kind of make the execution more private or privacy preserving?
I got it. Good question. So from our point of view, we don't need to put all the raw data onto a blockchain because some of the data needs to better be kept private. So, but the identification of the data can be put on top of the blockchain, and the identification of a piece of software, piece of application, can also be put onto a blockchain, and then the relationship can be recorded. It's like if we check this big ledger, we can actually know that which application has processed which data, but we actually don't know the actual data or the actual application without some privately held key or something like that. Yeah, so blockchain actually solve the auditing problem, but we can actually keep the most critical application and data private.
So the data application layer is separate. Something that we kind of discussed here is we have this kind of Trias system that you have set up, but how is it kind of different from the traditional blockchain, something like Ethereum that has Nakamoto consensus? How is this 3-layer system different from what we see classically?
Well, yeah. So actually, the real problem that we're gonna solve is the native application. We try to move the native application onto the blockchain. By native application, we can see as like the Microsoft Office, the entire application. So in order to do this, I think it might be really hard to reprogram, to recode all the Office source code, and to just re-implement them with Ethereum smart contract interface. The other way of doing this is that if we can just, for example, rebuild those applications and record all the critical paths and put them to blockchain, so that we can at a later time identify where malicious behaviors have been implemented. So this is one thing. And then for a second, if we can have a capability to know whether the actual application has been loaded, then we can, on the other hand, make sure that this piece of application has been actually executed. So regarding the differences between us and the other blockchain, is that we don't try to invent a new kind of machine programming language for every underlying software components. We try to make all the source codes relatively stronger and relatively trustworthy, and then we use our languages to assemble them to build a trustworthy application.
Right. So the difference here is that the client-side applications, you want them to be trustworthy via your separation of power, the Trias system, and then they can run natively on a smart device or on IoT devices. And then you're using the blockchain element here to make sure and record the mission critical parts to make sure that there is no untrustworthy execution. But you're not running every single bit of code on something like the EVM. You're running parts of it. So that's how the whole Trias system will work. It's really for allowing client code to also run.
Exactly. So we try to move the entire old world to a new world instead of building a new world from scratch.
And something that was kind of interesting when I read your white paper was the idea that you're looking for this -1 layer. So instead of scaling by layer 2, you're trying to build below that layer to make sure that you give trust to all the nodes in the network.
Exactly. So basically, our first layer, so the first component Leviathan, as I explained a little bit, it contains 2 layers. So the bottom layer is actually the layer -1 or layer -1, and the upper layer is what maybe we can call it layer 0. I see layer 0 as in all the other blockchains. So we dig 1 layer below and go deep inside the machine. So we got a trusted hardware embedded on the machine. So we use this hardware to record all the software behavior on that machine. So those software behavior are actually the consensus part for the other blockchain. So we actually allow the other blockchains, allow their nodes to identify whether their counterparts are running the correct code. So if we can make sure that all the joining nodes are running correct codes, I believe that it might be much easier for them to build a consensus, because most of the nodes are good guys.
Right. It's all about being fault tolerant or having malicious nodes, right? So the idea is that you're kind of weeding out malicious nodes before they even start joining and sending bad messages. One of the concerns I brought up here is that because Bitcoin, you can have multiple client versions, multiple developers. You can even develop your own variant of the Bitcoin, buy a technical white paper. You can write your own. So in that case, how do you, it's like kind of whitelisting a client. Do you whitelist clients? Because if if you do that, then doesn't that bring on centralization issues as well?
Yeah, it's a very good question. So currently we ask our community to identify the whitelist. For example, in order to tell whether an application should be put on whitelist, we can actually use the capability of the promise system. So if we see a new application, and then if we can tell how this application is implemented from another layer of a blockchain. So if it is the case, then the community will have the capability to identify the potential behavior of a layer 1 node itself. It's just like, so the separation of power model, they inspect each other. So for example, the Leviathan network is a trustworthy trustworthy computing system, and it actually helps the trustworthy building system, which is the second part. So on the other hand, the trustworthy building system actually builds the application for the underlying Leviathan network. So it's just like we got the small triangle at the first time, firstly, and then we allow them to circulate and expand the range of this system. I don't know whether I've explained it clearly.
So it's kind of relying on the second layer, right? The second layer about the client and the development part. So if you can follow the development part and record the execution of the clients, then you can know which nodes are trustworthy.
Exactly.
Let's go a little bit deeper into the use cases. Yeah. So we were kind of talking about how there's this idea of cloud computing and extending beyond cloud computing into the Trias system. So what are some kind of key industries that you're looking at to start with the first adoption of Trias?
Right. So currently we are developing our business in China. So because our first layer is actually the layer -1, so we can actually hold other blockchains. So we can accelerate Hyperledger Fabric and accelerate Ethereum. So we can pack them together to build a consortium chain solution. So our current strategy is that we sell this consortium chain to the local business in China. So we currently have got around like 16 user scenarios, big use cases, using our underlying technology to make sure that their data has not been tampered with, or their data has not been tampered with. And on the other hand, to make sure that unauthorized access to their data has been recorded. So, yeah.
Can you give us a particular example of an industry that you're targeting and how this can really help them, and also why they would choose to use this over just a traditional centralized database?
So our current strategy is that we use the blockchain to provide a trusted data layer to solve the local business issue. So when there are companies trying hard to trust other companies' data, we can move their application to our blockchain system. So we can build an entire solution for them. By doing so, we can actually earn money. We can earn. So we are currently expecting around like $7 million revenue this year. Mm-hmm. So we're currently building these large use case for around 16 big use cases, and we are moving their information system to Trias system one by one.
What is the current roadmap? So how ready is this network right now? And what's the current status? Are you in mainnet or testnet phase?
Yeah, so we have finished our first layer, the Leviathan network, the version 1 of the Leviathan network, and our testnet is actually up and running. So currently we got research team in Peking University and another research team from Oxford University. They are testing our testnet. So currently it's in the internal testing phase, and we are actually planning a hackathon with targeting at the research group from different universities. And our goal is to release our publicly available testnet by the end of this month.
Mm-hmm.
And by the end of in Q4, around Q4 this year, we'll be able to release our mainnet. And at that time, I think we'll be able to, since in China we have migrating the big use case one by one to our underlying system. So I believe that when we have got our mainnet up and running, we'll be able to migrate all those big use cases to our mainnet. And at that time, I think it's a little bit of chicken and egg problem. It's like if the blockchain, the public chain has no use cases, how can we attract developers to come here to develop application? Yeah, so our strategy is that we build a large use case for consortium chain, and we earn money, and then we migrate those chains to our public chain. So when our mainnet is on, we will got quite a lot of large use cases, and we will then welcome all the developers to develop application for those big use cases.
Then what is the use case of the token? So you got your own Tri token on, and what is the use case?
Yeah, so the Tri is actually the native currency of our entire Trias ecosystem. So when like the teams in the international ring wants to build a software as a service, just like maybe like a big software application like Facebook or the other kind of CRM or ERP solution. So they will need to acquire underlying trustworthy computing resource. They might need to acquire underlying trustworthy software components. So they might need to acquire some other services to allow them to combine this software and hardware to build a service. So they need Try TRY to acquire all these underlying resources. And at the same time, they can still write a smart contract to implement this big service and issue their own token.
So Trias, you guys going to go to do an IEO and then launching the mainnet towards the end of last year. So if you guys wanted to know a little bit more about Trias, how can we learn a little bit more?
Oh, yeah. Join our Telegram and log on to our Trias.one website.
Excellent. And I wish you the best of the deploying the mainnet. I hope I can follow up with you once the mainnet is launched.
Okay. Thank you so much, Michael.
Thank you so much, Doctor.